Hi, I'm Curt Frye. In this movie, I want to extend my analysis of the traveling salesman problem to incorporate the cost of additional drivers. The sample file I'm using, TSP Optimized Driver Count, is an Excel workbook you can download using the link that I provide in the video description below. I've gone through the basics of setting up a traveling salesman problem several times in this playlist, so I will skip through most of that and just give you a quick description of what I've done. I have 18 stations that drivers can deliver to, and those are here in the station list 1 through 18. And I have 18 stations, and each driver can do a maximum of 6 stations a day. So we have two possible solutions. We can either have 3 drivers that do all 6, or we can have 4 drivers, and some of the stations will be the virtual stations, which are here 19 through 24, and are at the same point as the starting place, which is station number 25. So you can see that 19 through 25 all have the same coordinates of 21 and 20. And then over on the right, I have the distance matrix, because we are trying to minimize, at least in part, the total distance traveled. Now let's go down and take a look at the routes themselves. The drivers can deliver from 1 to 18, but as we see in this solution, driver number 4 starts at 25 and then stays in place. They go to the virtual stations that are at the same point on the map as number 25. And if I look over at the route map, I see that we have those routes laid out. And I also have the total distance traveled for each of the drivers. Below, I've changed the total cost, which is our objective cell in G44. So instead of just miles, which is what we were doing earlier, I also incorporate the number of drivers. So I have the number of miles multiplied by the cost per mile, and then the number of drivers multiplied by cost per driver. So if we can save distance by bringing in another driver, if the cost is right, then we can optimize our delivery and do better with 4 drivers than with 3, even though there is additional cost. So let's see what happens if I start with our current configuration. And to make sure that Excel built its own solution, I'm going to set all of the starting values to 1. Now I can go to the Data tab of the ribbon, click Solver over on the right, and I have my objective cell, G44 total cost. We're trying to minimize it by changing the cells B30 through E35, and those are the ones here in yellow. We're using the evolutionary solver, and as part of the options, which we can see on the evolutionary tab, I have require bounds on variables, and that explains 2 of my constraints. The first constraint is that all of the changing cells, the variable cells, must be greater than or equal to 1. That's because of the different criteria we have here. They must also be less than or equal to 24. That is the total number of possible stations. And they must all be different. When you have an all different or diff criterion or constraint, then you have to start at 1 and go up to the number of changing cells. Okay. That's a fairly long explanation. I'll click Solve and come back when Excel has found a solution. There we go. I will click OK. And here we have 4 drivers. Okay, 341 miles. And cost per driver 150, so we have a total cost of $753.45. And when I look over at the solution on the map, honestly, it doesn't seem like it's all that great. I mean, the number of miles seems a lot higher than it should be. So let's make a small adjustment. I'm going to make the cost per driver 100 instead of 150. I will reset the starting grid in yellow to 1, and I will rerun the model and come back when it's done. Okay, we are back, and I will click OK. And here we have a solution that makes a lot more sense. We have 277 miles, 3 drivers, and total cost of $424.65. And when I look over at the solution, we have a crossing point here. So what it seems like is that we didn't get the best solution, but what we can do is go from the starting point to this point first and then loop around. And then it's likely that we will save a little bit of distance, but not a whole lot. So it's a small improvement, but it looks like we have a pretty good solution. And what probably happened in the previous run is that because we're using randomness to generate our solutions, Excel, or rather the evolutionary solver engine, probably got stuck at what's called a local minimum because we're trying to minimize our value, and it wasn't able to get away from it in time before it hit one of its stopping criteria. So let's do one more. And for this one, I'm going to increase the cost per mile to 1 and the cost per driver to 250. So with all of that in place, I'm going to go back up. Actually, I will reset I'll do it to 2 this time, just for a little bit of variety. Doesn't really matter. All the values are going to change from 1 to 24 in a moment. So I have Solver on the Data tab. Click Solve, and we'll do one more run. And we're back. I will click OK. And here I have what looks like a very nice solution. We have some circular or almost circular shapes. So all of the routes make a lot of sense. And when I look over here, I see that in fact, rather than having one driver that skips some stops, it appears that we have driver number 1 going to 20 and 19, which of course are virtual stations. Driver number 2 goes to all real stations. Driver number 3 goes to 1, 2, 3 virtual stations. So it appears that they only make 3 individual stops. So that would be the green here. And then driver number 4 has 1 virtual station, number 24. So they only visit 5 of our stations. And you see the total here. And that's what's so interesting about this type of problem. Not only can you get stuck and find a solution that actually isn't all that great and you should probably rerun, but you can also find scenarios where when you combine things, you will get some very interesting takes. So we have one route that is very short, one that is much longer than the others, and 2 that are kind of in the middle distance. And it's not all that important when you're planning things out. However, if your drivers have time constraints and you need them back in the warehouse for other duties, then sending someone out for 41 miles is a very different prospect than sending them out for 100. Thanks again. I encourage you to use this worksheet and explore to find solutions to problems by mixing up the cost per mile and the cost per driver.